What if I told you humans started flying, using just fire and fabric more than 200 years ago? Today, we're diving into the fascinating science behind the hot air balloon. From ancient inventors to modern skywriters, what makes this giant bubble float through the skies? Stay tuned. You'll never see hot air balloons the same way again. The hot air balloon was invented by French brothers Joseph Michel and Jacques-Étienne Montgolfier in the 18th century. The first hot air balloons were made of paper and textile, and the air inside was heated by burning straw. Hot air balloons have limited maneuverability. They can't turn left or right like airplanes. However, a skilled pilot can influence the flight path by adjusting the altitude to catch different wind currents at various levels. A hot air balloon is made up of three main parts. The envelope, a large, durable, heat-resistant fabric. The basket, or gondola, made from lightweight yet strong materials like willow or rattan. The burner system, which heats the air inside using a propane-butane gas mixture. These parts are connected by load tapes, allowing the whole structure to rise safely. To control ascent and descent, the pilot opens a valve at the top of the envelope. This lets hot air escape, lowering the balloon, or allows more heat to stay in, lifting it higher. The typical envelope volume for a balloon carrying 3 to 5 people is around 2,500 cubic meters. It's all about Archimedes' Principle. When the air inside the balloon is heated, it expands, becomes lighter, and some of it escapes. This reduces the overall density inside the envelope. Because the outside air is heavier, it pushes the balloon upwards. This is called buoyant force. As the balloon cools, air contracts and more enters the envelope, increasing weight. If this weight becomes greater than the buoyant force, the balloon begins to descend. If you enjoyed this journey into the science of flight, give this video a thumbs up, subscribe to Model Minds 3D, and hit the bell so you never miss a mind-blowing model. See you in the next video, where we turn science into visuals.